a quick hello in the chat. Hi, everybody. My name is Ryan Jacobs. I'm an instructor with Manhattan Prep. Apologies for the technical difficulties, but I think we should be good to go now. So give me a quick hello in the chat. Let me know that you can hear me. And I'll be trying to monitor the comments. They may be coming fast and furious, so apologies if I don't see your comment. You can just type it again. But otherwise, let's go ahead and get started. We weren't able to get the quiz going, so let's do this slightly differently. I have a set of 8 problems here, and they're all somewhat challenging. So let's do them one by one. And what I'm going to do is I'm going to give you 3 minutes to do each problem, which is, for a challenging problem, pretty reasonable for the GMAT focus. And just give it a shot on your own, and then I'm going to come back on video, and we're going to talk about it. All right? So you can see the first one on the screen. Why don't you go ahead and give it a try, and 3 minutes starts right now. See you in a bit. Okay, so go ahead and submit your answer in chat. And at this point on the test, you'd probably want to guess on this question since it is a timed test. And, if you don't know it, you don't know it. The other thing is these Roman numeral questions, sometimes you might have gotten 1 and 2, but not 3. You might have gotten some of them, but not others. So this is a good opportunity to guess. And remember, if you have time at the end of the test on GMAT Focus, you can always go back, which is like my favorite feature of the new GMAT Focus, is you can go back and change up to 3 answers at the end of the section. So if you're not sure on one of these, just take your best guess, and then you can always go back to it later. All right, so let's start looking through this one. This is a really fun problem. Let me get my pen working here. Number 1 is true. And I want to show you why. This is actually something I've sort of thought about in advance before I saw this question. And if you think about a regular number that's not a perfect square, like let's take the number 70, all the factors are going to be pairs, right? You're going to have like 1 times 70, you're going to have 2 times 35, you're going to have, let's see, 5 times 14, and you're going to have 7 times 10, right? So you always have pairs of these factors. And so in a normal number, the number of distinct factors is going to be even, right? Because they're all paired off. The one exception, though, is a perfect square. So like the number 25, for example. You're going to have 1 times 25, but you're also going to have 5 times 5, right? Whatever the square root of the number is, that's the one that's not paired off. And so everything comes in pairs except for that one additional one, and that's why you always have an odd number of factors for perfect squares. And so that's the proof that number 1 is true. All right. Now, here's where it gets really fun. We know number 1 is true. I'm going to leave that one there. When I took the real test, I had to just pick example numbers at this point. So I didn't know about 2 and 3. And so what I started doing is I just said 1, 4, 9, 16, 25, 36, etc. What is going to happen? And let's look at the distinct factors. So here it would just be 1. Here it would be 1, 2, and 4. Here you would have 1, 3, 9. And let's just see how high it can go. 16 has a bunch, so that might be worth checking out. 1, 2, 4, 8, 16. 25, we can throw that in there. 1, 5, and 25. And then 36 is going to have a whole bunch. So I'm going to try and make sure I don't miss any. 1, 2, 3, 4, 6, 12. You guys might need to help me out here because I'm going kind of fast, but I don't think I missed any. 18 and 36. Oh, 9. Forgot 9. There we go. All right, so let's see if the sum of these is odd. Well, this would just be 1, or 1 plus 2 plus 4 is 7, or 13. And then at a certain point, maybe you don't have to check them all. Maybe you can just look and see, well, most of these are even, but then plus 1, so that's going to be odd. So it looks like this is going to be true. And then the number of distinct prime factors of n is even. I can already tell that's not true for some of these because, for example, the number 4 has only 1 prime factor. And 1 is not prime, by the way. Prime has exactly 2 factors. So I already have a counterexample for number 3. So I will tell you, if I were doing this test on the GMAT, this is probably how I would do it, is just pick numbers, because number 2 is very, very hard to prove. You can prove it. It's kind of fun. I encourage you guys to give it a try. And if you're interested, I'll give you a little hint. You have to prove that the number of even factors is even. That's the trick to it. In a perfect square, the number of even factors is always going to be even. And so, you know, for that reason, since it has an odd number of factors total, if there's also an odd number of odd factors, then the sum is going to be odd. But that's a long proof. You'll never have time for it on the GMAT unless you've thought about it in advance. So great opportunity on this problem to pick numbers. All right, let's go on to the next one. And by the way, something to know, all of the 8 problems except for one that I'm showing you today are ones I got wrong when I first took them on a practice test. So it makes you feel better. I'm a professional GMAT instructor and I miss these from time to time. That's why I picked them out for you. Thought it would be fun. All right, here's the next problem. I'll give you all 3 minutes. Give it a shot. Okay. So take your best guess in the next 10 seconds or so. And this problem, I mainly want to show you a cool little technique. This is one I teach in my classes a lot for these types of problems. We call them overlapping sets problems. You can draw a little 3x3 grid. So I'm going to draw it here. And then I'm going to make 3 columns. And I'm going to make 3 rows. And the third column, by the way, I'll try and make this line a little thicker. The third column is always a total. And the third row is always a total. And here's the trick. Make sure that when you label your columns, they are mutually exclusive. So in other words, you can either be a writer or you cannot be a writer. And then for the rows, you can either be an editor or you can not be an editor. Nobody is in both columns. Nobody is in both rows. So you would not, for example, want to label your columns W and E. You need those on separate areas, right? Because there is some overlap between those. For example, they say X people are both writers and editors. And so I need some box, in this case X, where that's going to go, right? So let's just go one by one through these numbers. We have 100 people. I'm going to put that in my total number of people. 45 of them are writers. That's going to go in the total number of writers. More than 38 are editors. This is the sneaky part of this problem. So here's what I'm going to do. I'm going to say this is more than 38 in this box here. And then X are both writers and editors. We have that already. And then 2X are neither writers nor editors. So that's going to go here. Now, we have this problem that asks us what is the largest possible number. We call that a maximization problem. And then since they're asking about both writers and editors, we're going to try to maximize X, right? Because both writers and editors is that X. So that is our goal. All right, so here's the trick with using this grid. And I can see some of you are figuring out it in the chat before me telling you, which is awesome, awesome, awesome. Because you can see if I have 2 actual numbers in this bottom row, I can always find the third. I know that this has to be 55, the total people that are not writers, because it needs to add up to 100. And what's cool about that is now I have this column, right? I can write up top here, this is 55 minus 2X. And so you can see if I add the top row across, that's going to be X plus 55 minus 2X. Is going to be greater than 38. Apologies for my bad handwriting here. Hopefully you can read it okay. But that will be greater than 38. And now we have an inequality that we can solve. And by the way, I believe the mistake that I made the first time I took this test is I misread this more than 38 are editors as at least 38 are editors. And so I actually made it a greater than or equal to sign instead of a greater than sign. And so that led me to the wrong answer. So try not to make the mistake that I made. Read it carefully. It really says more than 38 are editors. So not exactly 38. That's not a possibility. OK, so if we solve this inequality, we're going to get 55 minus X is greater than 38. Subtract 38 from both sides and add X to both sides. We're going to get 17 is greater than X. And so X has to be somewhat less than that. And the greatest we can make it is 16, the correct answer. And Arya, you made the same mistake as me. I'm in good company. It's okay. But that actually brings up a good point, is that I think one of the biggest traps is a language trap, not a math trap. And that's something to keep in mind whenever you have these word problems on the GMAT Focus, is like sometimes there's a trap answer for people who just misread it in a particular way that the GMAT knows you're going to misread it. And so if you ever make that error when you're practicing, it's good to identify, oh, I'm not bad at the math, I'm bad at the reading part. And so next time I see that phrase, I'm going to be ready for it. That was my review point when I did this problem as well. All right, nice work, guys. Let's go on. You guys are doing great. I'm going to show you another problem. Take a look. I'll give you 3 minutes. Okay, go ahead and type in your answer to this one. And actually, just for fun, let's do 2 at a time this time. So I'm going to show you another problem. I gave you slightly less than 3 minutes, but go ahead and do this one, and then we'll talk about both problems. in the next 30 seconds or so. Take your best guess here. Okay. Cool. So let's take a look at this one first. There's a trick here. And first of all, I want to mention, you guys might have seen the variables in the answer choices, right? See how y cubed, y squared. There are y's all over the place in these answer choices. Normally on a problem like that, I would just pick numbers. I would just say, let's say y is equal to 2 and see what happens. But I was prevented from doing that here because this equation makes it a little bit hard for me to pick numbers, right? I was looking at this equation and I was like, I don't immediately see what it could be. It's probably like 1 and 3 or 2 and 3 or something like that, you know, because I see these 18s and these 3s. But I'm just not sure I could find numbers that would satisfy that equation quickly enough. So I have to do the algebra. And that's going to be, I think that's going to be the only method I can think of, unless you can find numbers that actually work. So to solve this, there's a little trick that I've seen before, and I wanted to share that with you in case you guys see it. This x squared y squared can actually be rewritten as x times y quantity squared, right? So that is the same thing. Equals 18 minus 3xy. And now I'm going to treat this like any other quadratic, where I'm going to move everything over to one side and I'm going to have a 0 on the other side. So xy quantity squared, add 3xy to both sides, and then subtract 18 from both sides. And that's going to equal 0. And what's cool about this is now you have sort of a standard quadratic, right? If I had n squared plus 3n minus 18 equals 0, you would know exactly how to solve that, right? Just factor it out. And so 18 is going to be, let's see, that's 6 and 3. So n plus 6 times n minus 3 equals 0. And so what we can do is just do the same thing, but instead of n, we have the combination of xy. And that's what I wanted to show you. I've seen the GMAT use this trick on more than one problem. I've seen it a few times, where instead of just saying a single variable, they give you a pair of variables that comes together. But you can still do the same thing, and you can solve it the same way. So I now know that either xy plus 6 equals 0, or I know that xy minus 3 equals 0. However, there's one more little sneaky trick they throw in there, which is the x and y are positive. And so if xy plus 6 equals 0, we've got a problem, because xy would then equal negative 6. That can't happen if they're both positive. So I know that we must have a situation where xy is equal to 3. And I believe that that's the part I messed up when I saw this on my practice test. I couldn't figure that out, and I solved the left side by accident. So I'm going to do it right this time. I'm going to solve for x, which is 3 over y. But of course, the problem asks for x squared. And so you can see that's going to be 9 over y squared. So correct answer is going to be D. If x is 3 over y, then x squared is 9 over y squared. Fun little problem, huh? A lot of you guys got that. Did anybody try to pick numbers? Let me know in chat while I go on to the next problem. I'm curious the strategies you guys tried to use. And feel free to ask questions along the way as well. I know I'm going fairly fast here, but this one is another one where I just sort of have a built-in strategy. I would think of this as a weighted average problem. And the key piece for me is this 60% of the population lived in the South. I think of that as 3/5 lived in the South. And so when I make a weighted average bar, I know that, let's say all lived in the North and nobody lived in the South, versus nobody lived in the North and everybody lived in the South. Again, sorry about my handwriting there. I think you get the idea. We are right here. Right? We are in this spot where 3/5 live in the South. So in other words, we're 3/5 of the way along the spectrum. So all I have to do is think, well, if everybody lived in the North, the population growth would be, actually, that's what we want to know, right? That's what we're trying to figure out. And if everybody lived in the South, the population growth would have been exactly 4.5%. And where we are is the population growth is actually 5.5%, right? And so all I need to do is figure out what would this number have to be for 5.5% to be 3/5 of the way from here to 4.5%, right? And you can do that with math, but like the answer choices are easy enough here to just plug in. It certainly can't be 1 or 3.5 or 6.5 because I know that would make an imbalance, right? Like 6.5, this number would be exactly in the middle. So it looks like 7% is the only reasonable possibility. And indeed, if you plug that in, you're going to see, from 4.5 to 7%, 5.5 is 2/5 of the way along, or going the other way, it's 3/5 of the way. So if you just think of this as a weighted average and you use the answer choices to your advantage, I feel like that's a little faster than actually trying to do the math here, but it's up to you. So curious, did anybody do it a similar way, or did you guys do the write out the algebraic equation, which you could also do, and that's fine. And as you are typing that in chat, we're halfway through. So let's go on. I think I'm going to do the same thing. I'm going to give you guys 2 at a time. Let's start with this one. And I'll give you, let's say, 2.5 minutes. Go for it. 30 more seconds for this one, then we'll do another one. Okay, here's one more. Okay, in the next 30 seconds or so, take your best guess at this one. Okay. So let's go back to the other question here. This one, I basically wanted to show you the trap. We know that this is 5 to the 13th. And we know that this is 5 to the 12th. So they're trying to trap you into thinking that this is 5 to the 11th and this is 5 to the 10th. But that is not true. I heard another teacher call this the Homer Simpson answer, right? You guys know Homer Simpson. Don't. He's always like rushing through things. He's going to make that mistake. So don't pick the answer that Homer Simpson would pick. 5 to the 10th is a trap. And the reason is they tell you that all of these spacings are equal, right? They're equally spaced. So this distance is the same as this distance is the same as this distance. And of course, exponents grow exponentially. They don't grow at the same rate. So 5 to the 10th is the wrong answer. Instead, what we're going to do is we're going to measure this distance. And we're going to say it is 5 to the 13th minus 5 to the 12th. And so my solution to this is let me take where we are and let me just subtract this distance 1, 2, 3 times. And then I'm going to end up at A, right? So if I take 5 to the 13th and I subtract 3 times 5 to the 13th minus 5 to the 12th, then I should be good to go. All right, so let's do that math. I actually didn't do this before the session, so I hope I don't mess this up. I think I can handle it. But I'm going to factor out 5 to the 12th here. So this is 5 to the 12th times 5 minus 1. And whenever you guys have like a plus or minus sign and you're dealing with exponents, that's probably going to be the trick, is you're probably going to have to find some sort of common factor. And so in this case, 5 minus 1 is going to get me 4. So that would be 12. 5 to the 13th minus 12 times 5 to the 12th. But I now realize I've done this in a way that doesn't help me with the answer choices. So I think I have to factor out 5 to the 13th as well. So that's going to be 5 times 5 to the 12th minus 12 times 5 to the 12th. And does that get me an answer choice? Yes. All right. So I probably should have looked at the answers before doing the math, but that's going to end up at answer choice 2. But again, I think the trick to this problem is the equally spaced part and just thinking about what that actually means. Again, it's sort of a linguistic trap more than it is a mathematical trap. And the rest of it is just exponent manipulation. So make sure you know how to deal with this situation by factoring something out. I've seen that a lot on the GMAT, and it's such an easy thing to, well, I shouldn't say easy thing to fix, but you know, with study, it's like something you can and should fix if you're making mistakes on exponents like that. So there you go. I also saw the comment in the chat, maybe I just don't like D as an answer choice. Yeah, D is the correct answer to this one. And it's also, by the way, the correct answer to this one. I didn't do that on purpose. It's just a coincidence, but maybe there's something to that. I will actually say, though, I remember this problem. It was the very last one on my test. And I think that's why I missed it, because like, I think I can do it. It's just such a linguistic mess, though, that it was hard for me to sort through, especially on like the very last question of the section. We'll give it a shot. And here is, I'll tell you one thing that I thought was useful. I drew out the satellite and I said, some have been upgraded. We don't know how many of those are, though, on each unit, right? So here's one unit. But we do know that each unit has the same number of non-upgraded sensors. And so I just called that X. Okay. Now, here's the trick. I had a teacher, and I want to give credit to the right person. It was another Manhattan Prep teacher. I think it was Jamie Nelson, but I might be misattributing that. Anyway, she said, if I can't do it with one variable, it's not worth doing. I thought that was really funny. I think it's a little extreme. I'm not, you know, I use 2 variables and 3 variables sometimes on the GMAT. But her point was a good one, because what she said is, like, on a problem like this, if you have X non-upgraded sensors, well, look at this sentence really carefully. The number of non-upgraded sensors on one unit is 1/5 the total number of upgraded sensors on the entire satellite. That just means that there are 5x upgraded total. Right? In other words, she did not assign a separate variable for this. She just took this sentence and said, well, I've already assigned X, so I'm just going to say there are 5x upgraded sensors total on the entire satellite. And since there are 30 units and there are X non-upgraded per unit, I know that there are 30X non-upgraded total. And actually, as I'm doing this, I now remember my mistake. Again, don't think of me too poorly because this was the last question on my test, as I said. But I believe I said the answer is 1/6, which is just a bonehead mistake. I got so excited, I thought I had the answer. But in fact, the question itself asks what fraction of the sensors on the satellite, in other words, of all the sensors. So there are actually 35X overall total. And so instead of taking 5 over 30, I think we have to take 5X over 35X. And that would be 1/7 is the correct answer. Yeah. So I got a good question in the chat. What range of difficulty would these questions be? Definitely all hard, except maybe the number 3 and number 4, which were the exponent one, where we had the answer was 9 over x squared, and then the one right after that. Those would have been considered medium to maybe difficult questions. But yeah, I picked these out just especially for you guys, because I know you're all in GMAT Club. You're all good students. Figured I'd give you a little challenge. And like I said, most of these were ones I missed myself on the practice test. So I also, by the way, picked these because there are like particular strategies that I feel like would be helpful. And so for this one in particular, I feel like that strategy about once you have X, trying not to assign a second variable, I feel like I've used that a lot. And it's something I think about a lot, especially when I have like this complex word problem that I have to translate into algebra. If I can minimize the number of variables I'm using, that's always going to save me time. All right, so we got 2 more to do. 2 last problems. And again, I think I'll give them to you kind of at the same time here. Let's do it. Y'all ready? Give this one a shot. I'll give you about 3 minutes, and then I'll show you the last one. Okay, let's see the last one. One of my favorites. Okay, so take your best guess. Probably was not enough time to solve it, but you know, gotta have some stuff to talk about. Maybe you were able to solve it. But there is always a time crunch on this test, which is actually kind of my lesson for this one. I want to show you guys something. I missed this one, but I'm actually not too torn up about it. I think I still made a good decision because I remember when I saw this problem on the test, I was a little crunched for time. You know, I was looking to make up maybe 1 or 2 minutes. And so I saw this problem and I thought, you know, we have 5 seats, right? So I'm just going to draw the seats in this car. We have 2 in the front and, you know, here's the steering wheel. Or whatever. And then we have 3 seats in the back. This is what the car looks like. And I said, if we had no restrictions, the answer would be 5 factorial, which I know is 120, right? And if you guys haven't studied combinatorics before, just know that if I want to know how many different ways can I arrange 5 people if there are no restrictions, the answer is 5 factorial, right? I can put them 120 different places. But then we have this restriction that one of the parents must drive. And so only 2/5 of those are going to work, right? With that restriction, the answer would be 120 times 2/5, which is 24, 48. Okay. So at the very least, or at the very most, the answer is 48. But then I was like, well, the 2 daughters refuse to sit next to each other. So it's actually got to be less than that, right? The correct answer is somewhere less than 48 because that adds an additional restriction. So I was like, it's either 28 or 32. Let me just guess. I guess 28, right? The correct answer was 32. But look, if I'm 50-50 on the answers and I can get that in like 30 seconds, I feel like I'm already winning. And let me just guess my answer and move on if I'm not sure I'm going to be able to get the answer quickly. You know what I mean? And so this is a good lesson for the GMAT. Is like, it's not always about accuracy. It's also sometimes about time and like finding that balance and finding opportunities to, you know, maybe guess when you have an educated guess, I think is, you know, that's the decision that we always have to make. But yeah, as it turns out, I was on the right track. But but here's how you might actually do it. I actually found it useful when I went back to review this problem to work upwards instead of downwards. So I just said, assume that the father drives. Well, the remaining people are the mother, the son, daughter 1, and daughter 2, right? So normally there would be 4 factorial places I could put those, right? There are 4 of them remaining, there are 4 seats left. But what I can't do is put daughter 1 and daughter 2 here, right? So that's 1. And the mother and son, right? That's one way I am not allowed to do. I can't switch the daughters. That's 2 ways that I'm not allowed to do. I can't switch the mother and the son, right? Because then the daughters would still be sitting next to each other. And then I also can't switch both, right? And then there's another thing I can't do, which is I can't put daughter 2 here and the son here, right? So that's another thing I can't do. Then I can't switch those daughters. Then I can't switch the mother and the son. And then I can't switch both the mother and the son and both those daughters. So what I'm getting at is out of those 4 factorial ways that I can arrange the remaining 4 people, there are 8 that don't work because the daughters are sitting next to each other. And then I just took that and I said times 2 because the mother could also drive and there would be the same number of ways, right? So if the father drives, there are 4 factorial minus 8 ways I can arrange them. If the mother drives, there are another 4 factorial minus 8 ways that they can be arranged. And so the answer is 2 times 4 factorial minus 8. So that's going to be 2 times 16. That's going to be 32. And that is the correct answer. Yeah, and a lot of you guys had different ways of arranging these or solving this particular one. That's also good. You know, I'm just picking one way. But what I will say is I really like this problem because it's very typical of the GMAT in that you do have a factorial, but you also have other stuff. So I think a lot of people just assume that combinatorics is about plugging things into a formula, right? Either a factorial formula or a permutations formula or a combinations formula. And like those formulas are useful, but I can almost guarantee there's going to be something that's like simpler, maybe mathematically, but trickier to read or consider. And that's, I think, where combinatorics becomes really powerful. So that's what we kind of study, right? When we see these problems, like each problem is its own thing. Each problem has something individual that you have to apply to the formula, you know, to make it your own. Yeah, cool. All right, so last one. Like I said, I think this is my favorite problem of the set. I do have favorites, not gonna lie. 60 factorial is some huge number, right? So it's like 83 million gazillion, you know, blah, 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 blah. And then at some point, it's just going to get to a bunch of zeros. And we want to know how many zeros are at the end. That's what this problem is asking, right? If we actually wrote out this number, how many consecutive zeros would be at the end? So I thought I was so clever when I did this problem the first time. And I was like, aha, I know how to do this. Every time you take a number and you do times 10, you're going to add a 0 on the end of the number, right? So all I need to know is if I do the prime factorization of 60, right, or 60 factorial, and I break it down, right, so 60 times 59 times 58, you know, times 3 times 2 times 1, and I broke all those numbers down, you know, so 60 becomes 12 and 5, etc. You guys get the idea. You've done this before. Then the question is, how many tins would be down there at the bottom? And you can already see I found one, right? Because I found 2 times 5. And then I took it a step further. And I was like, okay, well, I'm going to have a ton of 2s. So it's really the 5s that I need to find, right? That's going to be the limiting factor. And so in 60 factorial, I know that there are going to be 12 of those, right? Because I have 60, I have 55, I have 50, etc. In other words, there are 12 multiples of 5 when you're leading up to 60. So I picked 12 as the answer, which was wrong. Somebody in the chat tell me why. I'm throwing it to you guys to take us home. What did I mess up? Does anybody see it? Yeah. Because 25 actually has 2 5s in the prime tree. Yeah, and 50 also has 2 5s in the prime tree. Yeah, and so if you look at the prime tree and you want to know how many 5s are in there, it's not just 12, it's actually going to be 14 of them. And yeah, as Tenmaya is pointing out in the chat, once you understand that that's what you're supposed to do, then you can just sort of do the division and look at the remainders, right? But it's not just that there are 12 multiples of 5. It's we got to know exactly how many 5s are in the prime factorization. And that's a different question because we might have multiple 5s, you know, from like 25, which is 5 squared, or 50, which is 5 squared times 2. So there are actually going to be 14 zeros at the end of this number. I thought I was so clever. I thought I had understood it fully. But I wanted to show you this problem also, guys, because this is one where a lot of people on the GMAT, they say, oh, I'm doing so badly because I'm seeing such easy questions. And I thought this problem was easier than it was, right? I was like, oh, yeah, the answer is just 12, right? Like, I understand what's going on. But it's a problem that had 2 traps, not just 1. And so these for me are the hardest because like I think I've got it and I think I know what the problem is asking, and then they threw me another curveball. So if you guys ever have this question where you have to count the 5s in the prime factorization, just be wary of like 5 squared and stuff like that. I've seen this trick a couple times as well. All right, cool. So just to kind of wrap this up, and then I'll throw it back to Abhijit. You know, in thinking about the GMAT focus, a lot of it is the same quant-wise as the old version of the GMAT. You know, you have a lot of the same math, not so much geometry is being tested anymore, et cetera, et cetera. But because of that, a lot of the same timing strategies you still have to consider. And I found the GMAT focus even more of a timing crunch than the old test because you just don't have as many questions, right? So there's not as much wiggle room anymore. And for that reason, like I feel like looking at some of these harder problems, it's really important to keep an eye on time as well as just an eye on, you know, how do I do it? And that's something I would encourage you guys to think about as you go forward. So hopefully you've gotten something out of this session. And thank you guys so much for coming. I'm glad to meet y'all. I'm teaching with Manhattan Prep, usually on Saturdays or so if you guys want to come check out one of our courses or anything. But other than that, yeah, thanks again. Throw it back to Abhijit.